Hello, everyone, and welcome to the Esri GeoDev webinar series. We started this series as a way to continue engaging in developer-related topics and discussions in between Dev Summits. We're looking forward to our Dev Summit conference, March 8th through 11th, 2022. Moving forward, in continuation of our GeoDev webinar series, we will continue to have new topics, advanced features, and additional functionality to share with you. So be sure to stay connected with us through our GeoDev webinar series page or any of our social media accounts at Esri GeoDev. We would love to have conversations like these taking place throughout the year so that when we do meet at one of these Dev Summit conferences, it will be as though we never stopped. We hope you get as much or more out of this webinar than you anticipated. Now we'd like to introduce you to our webinar, Get Ready for the ArcGIS Maps SDK for Game Engines. Before we get started, I'd like to go over a few items so you know how to participate in today's event. We've taken a screenshot of an example of the attendee interface. You should see something that looks like this on your own computer desktop in the upper right corner. You're listening in using your computer speaker system by default. If you would prefer to join over the phone, just select Use Telephone in the audio pane and the dial-in information will be displayed. You will have the opportunity to submit text questions to today's presenters by typing your questions into the questions pane of the control panel. You may send in your questions at any time throughout the presentation. We will collect these and address them during the Q&A session at the end of today's presentation. I would now like to introduce you to one of our presenters, Stephen Heidelberg. Stephen, let's get started, shall we?
Thank you, Amy. First, just a little background on who we are. My name is Steve Heidelberg. I'm the product manager for ArcGIS Maps SDK. I'm also joined by Rex, a fellow product manager. And last but not least, Adrian, our development lead, will be showing us a demo on the ArcGIS Maps SDK pre-release. Also, if you saw this year's plenary, Adrian provided a great demonstration of XR capabilities. So quickly, the agenda for this presentation is, I'm going to give you a brief overview and discuss technology benefits of game engines. Next, I'll touch on our release status. And then we'll look at the ArcGIS Maps SDK pre-release capabilities. I'll then hand it over to Adrian for an in-depth look and demo of the plugins. Rex will then talk on the exciting things we'll be working on in the future. And finally, we'll take some time for a Q&A at the end. So before we dig in, I'd like to provide a brief overview and background on how we got here. Over the past few years, we've seen a number of industries and businesses pursue their next generation of 3D GIS solutions. As these solutions apply to the real world, they need to leverage existing geospatial systems while taking advantage of new technologies to gather, store, and distribute GIS data. These new 3D GIS solutions include client applications that target specific workflows that require photorealistic experiences powered by real-world data. They also need to be highly interactive, responsive, and intuitive. They need to be designed to be visually compelling, immersive, and realistic as possible to increase engagement, improve understanding, and optimize the environment for making decisions. Operationally, they need to support modeling and evaluation of phenomenon in the real world, simulating natural and human-oriented activities, and the interaction between them in the past, present, and future. In addition, they need to quickly render dynamic real-time geospatial content accessible in the office and on the field for rapid analysis and decision-making purposes. It's important to note that game engines are the foundation for ArcGIS Maps SDK. We understand they're powerful tools for visualization and our users are asking to incorporate GIS into their solutions. Before we dive in, let's take a few seconds to isolate some benefits inherited by the game engines. These are features that exist outside of the ArcGIS Maps SDK plugins, but can benefit the plugin and GIS workflows. First and foremost, access to build out premium, high-definition rendering pipelines to deliver simulated world experiences optimized for multiple platforms. Of course, to build a more immersive and compelling experience, game engines also invested heavily in systems and APIs to simulate the real-time interaction and movement of real life. The introduction of high-fidelity assets, physics engines, animation properties, atmospheric, water, and other special effects has enabled some game engines to deliver beautiful, photorealistic, cutting-edge visuals that appear and operate nearly identical to the real world. Game engines also provide support for targeting a wide variety of desktop and mobile platforms. and dedicated specialized hardware. Part of the next generation of 3D GIS solutions include business use of headsets dedicated to extended reality workflows, such as HoloLens and Oculus Quest. Game engines are built to support the responsiveness, frame rates, and fidelity needed to power these experiences. Last but not certainly least, successful game engine vendors have existing developer programs and communities, help docs, forums, and tutorials. With that in mind, we're delivering the ArcGIS Maps SDK as a developer product that integrates with the two market-leading game engines, Unity and Epic's Unreal Engine. Both will be distributed as plugins and provide UI and APIs to access ArcGIS services and local data. This work is currently founded on support for local and global 3D experiences through a scene which provides the context to display and interact with geospatial data and honor real-world geographic coordinate space. The public can access the pre-release today by accessing the URL in this slide. So that's the high-level view of these new developer products. Let's take a look at some of the capabilities of the pre-release. So the Maps SDK development team started building these new products back in 2019. We released our first public beta 1 last October, and then beta 2 in February. In that time, we partnered with Unity and Epic Games, and we worked closely with Unity's geospatial team and Unreal Engine's development team to deliver a premium experience for developers who choose to use a game engine with geospatial data and capabilities from the ArcGIS system. This partnership enables support of native geospatial placement, which is required to support accurate geospatial placement of objects and intuitive camera control within a scene. Let's run down what's available in the current pre-release. Then we'll take a closer look at the status of the release coming in late Q1 of 2022. Keep in mind, functionality delivered in the Maps SDK for Unity and Unreal Engine is equal, while functionality and capabilities of the editors and engines themselves may be different. Unity supports deployment to desktop and mobile platforms. With pre-release, Unreal Engine only supports desktop platforms. But with the first production release, we'll support both desktop and mobile platforms. Rex is going to provide a little bit more details in the road ahead later. The Maps SDK provide a couple options for working with the plugins. Both include a UI to configure properties of the scene, set camera position, and add modify layers. Both include an API for developers to customize and deliver a solution in code. We also integrate with Blueprints, a visual scripting system in Unreal Engine. Shared functionality for both Unreal and Unity plugins are both local and global experiences are available. Next, as mentioned before, native geospatial placement is required to support accurate geospatial placement of objects and intuitive camera control within a scene. With this release, ArcGIS Maps SDK for Unity delivers initial support for native geospatial placement with the high precision framework, which was developed by Unity and integrated with the ArcGIS Maps SDK. Similarly, ArcGIS Maps SDK for Unreal Engine delivers initial support for native geospatial placement built on the georeferencing plugin for Unreal Engine 4.27. For both plugins, this means that global scenes now use a rebasing system and an ellipsoid model instead of the spherical model, which allows you to render large-scale worlds and place GIS data more accurately. It also introduces changes to the relationship between the camera and the GIS scene. Data sources accessible via plugins include a single elevation service for terrain. This means an image service hosting Lurk encoded tiles with elevation values. This includes ArcGIS Online world elevation services for terrain and bathymetry. Also, we support multiple raster layers, which include cache map or image data for display from a service or a local tile package or TPK. Sources include ArcGIS Online base maps with imagery, topography, or street data. To add to that, we support multiple 3D object or integrated mesh scene layers. 3D object scene layer attributes is the ability to work with 3D attributes that allows you to visualize the objects in a layer in a more meaningful way. This means making unique shaders like heat maps, highlighting building regions or floors, or emphasizing population indexes through colors. Next, a new version of the Index 3D Scene Layer, I3S, specification for scene layers has been released. I3S specification version 1.8 is supported by ArcGIS Maps SDKs for Unity, and that includes Basis Universal Texture Format and Chronos, KTX2 standard. Behind the scenes, we optimize the architecture of the ArcGIS Maps SDK to streamline performance and memory usage of GIS data. This architecture represents what we intend to deliver in the first production release. It's been open to the public for over a year now and has been incredibly successful. Currently, we have 4,000 participants, many actively engaged in the community, prototyping solutions and providing feedback to our developer team. At this point, most participants in the beta program are targeting a business or enterprise application, sometimes called a serious game. In that respect, we're seeing pervasive interest in the use of geospatial data and game engines across many industries. A number of the industries have already embarked on this effort and are pursuing targeted solutions founded on game technology. This is more than just gamification of GIS solutions, which is basically the use of game-style interaction patterns to drive and empower users of software. It's the use of game engines to build the next generation of 3D GIS clients and experiences on new devices with new expectations. These industries include AEC, defense, public safety, natural resources, government, education, utilities, and transportation. And now I'm going to go ahead and hand you over to Adrian for a demonstration.
Thank you, Steve. So first of all, I'm just going to go through exactly what you get once you join the beta program and how you can get all the SDK components and then how you can use them. So the first place, as Steve mentioned, is really our early adopter website. And this is the main hub where not only you can actually download the SDK, you can download the beta 1, beta 2, and the pre-release that just came out last week. But this is also the place to where we're gathering all the feedback and all the discussion regarding the SDKs. You'll see that we have a Unity and an Unreal Engine forum, and then we have about more than actually 4,000 users in that early adopter website right now. You also have link in there to the documentation for both Maps SDK for Unity and Maps SDK for Unreal Engine. This documentation has been completely revamped from the beta 2. So the structure is now really in line with the rest of the ArcGIS developer website. So we have the same type of landing page that actually can learn directly from the key features of the SDK, and that just lists everything that Steve just mentioned in his last slide. But you also have access to obviously how to get started, which means installing the right version of Unity or the right version of Unreal Engine, and then be able to install on top of that the SDK. And then tutorials to be able to start from scratch and creating a new app using the UI, or new app using codes, or new app using blueprints if it's Unreal. So, and you can see that we support, for example, global scene and local scene. And for each of those, once again, you have linked to a tutorial on how this can be done. The same thing is for the documentation for Unreal Engine. Once again, we're really treating those two game engines equally and put the same feature in both. We only have a limitation for this pre-release for Unreal Engine. As Steve mentioned, we won't be supporting mobile platform for this pre-release, and this is because we rely entirely on that new geo-placement framework given to us by Epic. And this geo-platform framework is actually not available for mobile platform in the 4.27 version of Unreal, but will be available for the version 5. So we're pretty confident that our final version, our first public release will support mobile to have a complete equivalency between Unity and Unreal Engine. But all the information, once again, can be found here, and you'll find exactly the same structure, except that in addition of being able to use code and then the UI, you have in Unreal the possibility to use blueprints, which is a scripting language. So the first thing I wanted to share is something that you won't be able to see as a new feature, but something that is gonna be really important for your development. So what I have here is Unreal Engine running in beta 2. And the graph you can see on the bottom left are basically the frame rate. The frame rate is actually in green, and you can see the number also of the frame rate on the top right of the image where the frame is displayed. You can see right now we are about at 16 or 17 milliseconds. And you can see that as I'm moving around, the performance decrease for a lot of frame, where sometimes it takes 40 milliseconds to actually display the scene. And just by moving around, you can see the increase and the decrease in the frame rate, and that's sometimes reach actually 40 milliseconds. And you can see when I'm just going from right to left, you can see that decrease happening, which is obviously not ideal in game engine, especially if you want to target VR experiences. So what we've been working on is a complete re-architecture, low-level re-architecture of our plugin to be able to allow that frame rate to be consistent. So now what you see here is another Unreal project, except this time I'm actually running pre-release, and I'm running the exactly same scene. And you'll see that when I'm navigating around, the frame rate basically never drops, never like take more than 20 milliseconds to render. Even when I do the same movement from right to left, I have now a frame rate that is basically staying around 16 or 17 milliseconds to render. So that's a huge performance work that we've been doing, and we actually started that work a year ago, and it came to life with this pre-release. And that's obviously something that we wanted to have to make sure we can release our first public version, and be able to run on VR headset. So that's the first huge improvement that is not really a new feature, but that I'm sure you'll be able to benefit from when you use our pre-release. Let me just get rid of that frame rate window now. So with pre-release, you have pretty much exactly the same types of SDKs that you have with beta 2, which means that it comes with a lot of samples. So you have the detail panel, for example, where you can set your scene purely using the UI. So you can see that on the right of the screen there. I can set where I'm going to start. I can set if I want a global scene first and a local scene. So global scene will be a sphere, when local scene will be a flat earth with still the 3D elevation and buildings, obviously. And then be able to set your camera location, your base map, and then add data either from a URL or from a local files. The layer UI changed a little bit. You can actually modify the URL directly in the UI. And then the generation of OAuth is still supported. So not many changes here, except that you still have access to all the samples that you had in beta 2. So you can run the scene using the UI, like I just showed you what the UI look like, and you end up with the scene I was just using earlier. You can set your scene using code in C++, and then when you press play, you end up with the same scene. That's only if Unreal doesn't crash on me, and obviously Unreal decide to crash on me. So what I'm going to do then is I'm actually going to move to Unity, and hopefully get Unity to work. Let me just at the same time just restart my Unreal Engine. So let's move to Unity, so I can talk about another capability that we are releasing with the pre-release. So with Unity, we do support two types of pipeline. We have the HD rendering pipeline, which is mostly used for really AAA games and really high fidelity rendering on pretty powerful hardware. But we also support the URP, Universal Rendering Pipeline, which is mostly used for more like mobile platform types of application. For both HDRP and URP, you have access to the same default samples. And the first one is pretty much the same one you have in Unreal, where you're able to set the scene either using the prefab, for example. So you can have the same type of UI that we just saw. Not going to go through that again, but same view mode, location, and then be able to select your layer and run your layer. And when I press play to this, to setting the scene with the UI, you will see exactly the same thing that we had earlier using Unreal Engine. One of the cool things of Unity is to be able to see that window on the left, which is kind of the behind the scene, like the director view of your application. And then the window on the right is actually your application. What's interesting here is to understand how we manage to get a very good frame rate even when we display data for the entire world, because you can zoom anywhere in the world. And you'll see that if I turn right, you will see on the window on the left that the data is unloaded, and then even the LOD is switching from a good LOD for the tile to a pretty poor LOD. And that's to make sure that we don't get the GPU overloaded with any data, and then we can get the best frame rate possible for our application. So that's the magic behind the scene. But for you, it's totally transparent. The LOD switching is taken care of by the ArcGIS Maps SDK, and your data is just loading and unloading as needed, depending on the view. So one of the big things that we just mentioned is the use of a new geoplacement framework, which in Unity is called the HP framework. So HP framework, high precision framework, got developed by Unity, and we work in close collaboration to be able to enable that capability, part of our ArcGIS Maps SDK for Unity SDK. So the first thing is game engines right now have a single precision, which is not enough, which is obviously close to the GPU, and that's why game engines have a single precision, but that's not enough to represent coordinate for the entire world. So to be able to represent that, we need a double precision system. And the work that Unity getting that double precision system by having basically two simple precision working together. So you'll see, if you're familiar with Unity, on the top right, you usually use the transform to be able to move your object. What you'll see here is that the transform got automatically collapsed, and instead we have an HP root. So the HP root is basically really the root of the single precision that will be added to another high precision transform that will be able to be combined to give you a double precision. So at the root of my prefab, I do have this HP root. So the thing I'll be able to do is, for example, add a sphere to my scene. I'm going to make sure that my sphere is under my prefab, so basically under my HP root there. And on my sphere, all I'm going to do is add an ArcGIS location component. What that does is not only add the ArcGIS location component that you might get that you might be used to if you've been using the beta 2 version, but it also does the same way and collapse the transform and instead use an HP transform to be able to deal with coordinate. So first thing I'm going to do is make that sphere a little bit more feasible. And now I'm going to do the magic where I can actually grab here in my editor view, I can grab that object and manipulate it to be able to bring it into my scene. So I want to make sure that it's over the island here, so you'll be able to start seeing it appearing in my scene over there. So the magic happens here where I can manipulate my game engine object in a very natural way for game engine developers. And you'll see here on the HP transform that that position that clearly is now a double precision is updated live when I'm manipulating my game engine object. But that's not the only thing. You can now look at the location component with the latitude, longitude, and altitude, so really the GIS coordinate of my object, and you can see it updating live while I'm manipulating my objects. So now you can actually interact with your game engine resources, which was one of the first feedback we got from beta 1 and beta 2, how really separated the GIS world and the game engine world were. With the pre-release, really those two worlds are now just combined, and you can manipulate directly using a GIS coordinate. So for example, I can change the altitude from 76 meter to 700 by manipulating the altitude here, and it gets automatically updated, not only visually, but also in my HP transform. And then I can do the same and in the altitude by just manipulating my game engine object. So that's a huge work and a very feature that I think is really going to help any user that is trying to combine some GIS component of their application and pure game engine resources and be able to get them to communicate and work together. And so we looked at, for Unity, the universal render pipeline, the HP render pipeline, and you can run your scene using the UI. We have a new component scene that basically collapse all the information on the for setting up your map inside the component. And then you have the API scene where you're setting your API, your scene using purely C# code. But any of the samples that come out of the box inside the SDK once you get it installed basically result in the same application, either you set it by UI, by component, or using the C# API. So I'm now going to try to reopen my Unreal application and go back to where I was. So I was describing how you can run your scene using, once again, the UI, and then be able to set all those elements in the UI here. And then when you press play, once again, you have the same scene that we just looked at inside Unity, but also already using blueprints inside the Unreal Engine. So you can set your scene using the UI. You can set your scene using blueprints. So you have a blueprint sample there, and then you can open the blueprint and then actually look at the scene, but I'm not going to do that, otherwise I'm going to have to share another window. But the thing I wanted to show inside Unreal is the new capability of using 3D attributes. So our scene layers have attributes associated with each of our features. So we could just render the entire scene using the default rendering that is baked inside your i3s data, so our scene layer. But the building scene layer, which is specific types of i3s data, have also attributes associated with each of the features in there. And you can see there that we're displaying the same scene, but there's a difference. It seems like some buildings are displayed in orange and some buildings are displayed in blue. So I'm going to show you quickly how you can take advantage of this new functionality in your own application. To be able to get to that rendering, there's actually two steps. There's the first steps, which is a pure UI step. So for this, I'm actually going to stop the scene and share my Visual Studio content. So when you're setting your scene by code, and that's exactly the same type of code you will have here in C++, but you will have exactly the same type of code in C#. And it will look exactly the same as doing it using the UI. So first you select if you want a map that is global or local, then you add your base map, then you add your elevation layer, then you can add your layers. That's exactly what the UI allows you to do, and every other samples using the API or blueprints allows you to do. And it's here listed in exactly in the same order. So it's really easy for you to understand switching from UI to API to blueprints, how it's done. But something new here is the ability to say, oh, I want to also add attribute types. So here we're considering two types of attribute types for the data we're showing in our samples. And some of them are really simple to deal with. It's the construction year. Why is that simple to deal with? Because all that code is going to do is to be able to pass that attributes to the shader. So here, all we do is that we're going to select an attribute and pass it to the shader. So if I go to what that function does, it's basically say, can you find that attributes in each of the feature that are in my i3s building scene layer, and added to my basically to my material later, so I will be able to access it at render time. So that's the new functionality, is to be able to add that attributes and then be able to consume it in your shader. If you have an attribute that cannot be consumed directly in the shader, like the name, for example, the name will be a string, and string cannot be used in shader. We actually have a mechanism where you can create a hook, and it's a little bit involved, but you'll see there's a lot of description in the samples that come with the SDK to explain exactly how you can do this. And then you'll be able to basically, for each name you're interested in, changing into a supported type. So right now an integer, for example. So that way, even unsupported feature type will be able to be consumed in the shader. So that's part of the API work you have to do to use that new capability. It's just basically telling the ArcGIS Maps SDK, this is the feature I want to be able to consume in my application. So the next thing you have to do in your application is to be able to go to the material. So for example, let's go to the year renderer that we talked about before. So I'm actually not sure here if you guys are seeing my material window or if you're still looking at my Unreal window. It seems like you should be able to see my material window. So Stephen, Rex, let me know if that's not the case.
Looks okay to
see it.
me, Adrian.
Looks good.
Okay, perfect. So so here you can actually see something that if you worked with materials and basically shader code in blueprints using Unreal, something that must look pretty familiar to you. But now what we can do is actually retrieve that attribute, which is a recent year here of year 2000, and then retrieve it from that basically array of attributes that is built in. And you can see, once again, that's what we specified in our API. But now I'm purely in the game engine, nothing to do with the ArcGIS Maps SDK anymore. But I can access that material and be able to say, oh, if my recent year is more recent than this number, which is the year 2000, represent my data in blue. If it's less, so if the building is older than 2000, then just represent my data in orange. So now, if I run this application, you understand why some of the buildings are in orange, which means they're older than 2000, and some buildings are in blue, which means they're newer, they've been finished and built since 2000. So let me show you how simply you can use that framework and change it. So if I go back to my contribution year, and maybe I want to change the year to be 2010, for example. And once again, here I'm purely inside my game engine code. I'm not dealing with the ArcGIS Maps SDK at all. And then if I save this and rerun my application, I see now much less building in blues. I think there's still some over there because those are the buildings that has been built since 2010 instead of the buildings that have been built in 2000 that it was before. So that functionality I just show you using Unreal, but that's totally the same kind of capability using Unity. And Unity, you'll be able to take advantage of the shader graph to show the same type of work using attributes. So the last thing I wanted to share is just some of the bits and pieces that we've been working on since we released our beta, and that's more like demos built on top of our Maps SDKs. The first demo, really just simple, see a satellite moving and really work on the lighting and the atmosphere effects that game engines can give you. Then this is something that we showed actually almost a year and a half ago during the Dev Summit, and the capability of putting your application on VR headset and how Game Engine makes that very simple. And this is just a simple view of the Grand Canyon. We also saw during the same Dev Summit a year, which was right after those devastating fires in Australia. We show how you can use the particle system to show the smoke and the impact of the smoke it had and how they could be viewed from space. But also like go deeper and use some more of the particle effect to show some of like game-like fires and be able to zoom into it and evaluate that. And that's where you have the border between GIS and different applications. Here, the data is coming from the this is actually a video from our UC plenary. I really encourage you to look at it because it really encapsulates not only what the ArcGIS Maps SDK are doing in game engines, but Esri as a whole. And you can see that the data is coming from the Maps SDK, or here I think is Vitruvio, but you can still take advantage of the game engine for atmosphere and different textures that you might want to apply to your data. Here we're using the same kind of technique that I just showed you, where we're changing, let me go back to that, where we're changing the material of the data to be able to show those, the inside of the building and those lights coming in and out. We also developed these fun games that we presented last year, just this big lizard walking down the city. And that's another video for UC plenary and another example of AR, VR that is used a lot by our customer, which is a tabletop scenario where you can project your data on a table and then use clipping area and different techniques to be able to show that GIS data on the tabletop. Obviously, you can use simulation. Here, the car simulation can come from real-world devices and be fed to the location component to be able to be animated. And that's one of the examples, once again, extracted from our UC plenary. And this is a quick example also how you can use, I'm going to go back to it, how you can use our ArcGIS Maps SDK to develop AR application. And you can see here how you can look at underground facilities. I'm just pausing there because the next section is about features that are available directly through an API in the runtime API, for example, or JavaScript API. But it's something that doesn't need to be included to the ArcGIS Maps SDK API. And the reason is that work can be done at the game engine level. So once we release our first public release that Rex is going to mention and talk more about in the next slides, we will have also associated with it a GitHub repo with a lot of samples, how you can do those things. And one of the samples will be the measure tools, for example, that is displayed here. And we'll provide the source code for here, so you'll be able to implement those functionality yourself. And that's another example of different simulation you can do. Here we're using purely the renderer and the edge effect to give our data different rendering. And that's pretty much all I've got in terms of just a few of the demo we worked on at Esri. And after that, I'm just handing it back to you, Rex, if you want to talk about what's coming.
Awesome. Thanks, Adrian. So definitely great to see some of the work that's gone into this pre-release and some of the work that Adrian showcased. Now I want to talk a little bit about the road ahead, like really the road to production for the ArcGIS Maps SDK. Now, just to reiterate, the pre-release is the first release to showcase the architecture that we intend to deliver in the first production release. The geoplacement framework was a big part of pre-release. We have what we need in place with the ArcGIS Maps SDK for Unity. We're still working on support in the ArcGIS Maps SDK for Unreal Engine. I'll talk a little bit more about that. Now, as you noticed, the geoplacement framework for Unreal Engine depends on the georeferencing plugin, which is only supported with Unreal Engine 4.27 on desktop platforms at the moment. Now, we need a more complete solution, which includes support from mobile going forward, of course. For this reason, we intend to provide a pre-release on a preview of Unreal Engine 5 before the end of 2021. Now, granted, this may depend on the state of Unreal Engine 5, so this, of course, is subject to change, but it's certainly our intention. Now, that said, our first production release, version 1.0, is scheduled for late Q1 2022. Now, based on some feedback, or quite a bit of feedback from our customers, we have a few enhancements planned for this first production release. First, support for editor mode, basically the ability to change properties of the scene, including adding and removing layers or objects, changing colors or transparency, and likewise, and seeing those changes at edit time. You no longer have to run the app to render the Maps SDK content to be able to see it. It's a pretty basic expectation for production-ready plugins, and we're going to have it in the first release. Next, we'll enable the ability to use a wide variety of spatial references, not just Web Mercator and WGS84, but those in other projected or geographic coordinate systems to match customer data. This is really the bread and butter of GIS and Esri. Customers need to use their geospatial data in the most appropriate coordinate system available. And finally, we plan to build out a complete world-class SDK. We made some progress on this in pre-release and enhanced our documentation, but we also need to include public samples and demos that showcase how to use the Maps SDK to deliver things like AR and VR experiences or exploratory analysis, such as viewshed and line of sight, using capabilities that are built into the game engine. And of course, we'll also keep our options open and see what else we can include in this first production release. Now, keep in mind, this is just the first of many releases to come. We're just getting started. This is a new developer product. Now, with that in mind, what do we plan to target in the future? Now, here's a list of what we're considering based on customer feedback. Now, what you'll notice is really a host of additional ArcGIS layer types. Now, one of the primary benefits of the ArcGIS Maps SDK is enabling access to ArcGIS datasets, both through services and local packages in a game engine. Some of these datasets deliver complex payloads, such as scene layers and vector tile layers, where it's not easy to create a reader or manually request, process, and render data. So for this reason, we plan to tackle some of the most complex layers first, such as building scene layer, an I3S representation of a building information model, and point cloud layer, an I3S representation of LiDAR. Dynamic map services and feature layers are common and will be delivered in the future, but in the meantime, as developers, you can leverage existing web request systems in the game engine to manually request and handle responses and use the game engine to symbolize and render. Now, one layer we're also excited about in this feature is stream layers. These are basically feature layers with a stream service as their data source. They're really designed to handle real-time information, often a lot of real-time information where observations are live. Now, with respect to capabilities, we want to enhance the ability to query geometry and attributes from ArcGIS layer types that support it. Now, we made some progress in the pre-release with the ability to access attribute values of nodes in a 3D object scene layer. We want to expand that approach for more explicit query and identify operations. Another important option actually is the ability to accommodate for different or missing Z values in data, or to improve visualization of operational data by modifying or changing the elevation offset. Bottom line is we need to explore more control in this space. Now, also the use of elevation and other layers as a collision mesh is important to establish and interact with content as bearers in a scene. This includes impeding a camera or object movement through a mesh, or utilizing physics to show objects, soft and rigid bodies, reacting to a mesh or surface. This is possible to some extent with custom developer workflows today, but we can do more to assist that. Similarly, enabling proper support for traces or raycasting, basically hit testing, objects in a scene in an effort to place or select objects, but respect geospatial context and coordinates. So both collision mesh and raycasting may be coupled with enabling the ability to choose a single level of detail for elevation layers, both for visualization and interaction. So currently an elevation layer source is a cached tile set where different levels of detail are retrieved based on a viewpoint in the scene, optimized for visual performance. You may need to specify or lock to a specific LOD, so an explicit set of tiles will be used and persisted to act as a mesh for collision or manipulation, or representation as terrain or landscape, or even just showing the appropriate level of detail for an area of interest instead of relying on the display optimizations built into the Maps SDK. Now, the last item listed here is ArcGIS symbology, which includes simple definitions and sophisticated cartographic models. We need to determine how to deliver ArcGIS symbology for effective use within a game engine. Now, this may involve support from services and packages, but also include distributing and accessing styles. We'll need this for a consistent representation of symbols across the ArcGIS system for a variety of industries with extensive symbology demands, such as defense, public safety, and utilities. Now, I've added the ellipsis at the end to indicate that there are quite a few additional opportunities going forward. So we'll be working with our partners and our customers. We'll be working with you to assess needs and priorities as we go. We'll keep it dynamic, and as time goes on, we'll see these priorities crystallize and these enhancements start to come together. I want to finish with a reminder that our beta program is open to the public. The link to join is available in this slide. Any feedback on the Maps SDK deliverables, beta or pre-release, or any questions on our developer efforts with game engines can be handled in the beta program user forums or feedback channel. Also, feel free to use the beta program to share details about any use cases you'd like to target and discuss. Now, with that in mind, I'd like to hand it back to Steve for the Q&A portion of this webinar, but I'll leave this slide up in case you need this URL. Steve?
Thanks, Rex. Yeah, we got a lot of good questions. If we don't get to yours, feel free to post your question on the user forums as well, and we'll get back to you in a timely manner in that way. Let's go ahead and get started. This first one is probably for you, Rex. Does the SDK support data input from the ArcGIS Enterprise?
Yes, actually, as I mentioned, one of the pivotal or key capabilities of the ArcGIS Maps SDK is access to ArcGIS data sources. ArcGIS data sources can be available through services or local packages. Enterprise has the ability to host different service types that we do support, such as 3D object scene layers, integrated mesh scene layers, worked with raster tile layers, and elevation layers as well. So there's a variety of other additional layer types that we'd like to be able to support going forward, as I mentioned in the previous slide. But it's designed to work with the key parts of the ArcGIS system, and those key parts, those pillars of the ArcGIS system, are our desktop, or basically our authoring capabilities with ArcGIS Pro, and being able to publish and distribute data through ArcGIS Enterprise, which is your own private cloud, ArcGIS Online, a public cloud, or data that we host and make available for you through ArcGIS Platform. So ArcGIS Enterprise is one of those key pillars of the ArcGIS system that enables you to publish and distribute data, and that data can be used either as services or by packages generated by services from ArcGIS Enterprise.
Okay.
Good question.
This next one is for you, Adrian. Does this 3D engine support temporal data like raster catalog or netCDF?
The short answer is no, not out of the box. That's definitely something I think that probably one of the future support that I don't know, Rex, you had that part of your slide, but it's definitely in our roadmap to be considered to be able to have temporal data support. So there's a few things that can be done. Is that there's the data that we support out of the box, which just means you can enter your URL and then be able to consume that content. But you have also opportunities, which is be able to use the REST endpoint for a lot of the other types of data that are hosted inside the ArcGIS platform. And this is something that will provide a sample for once we have that GitHub public sample repo that will be released with our first public production release. And that will show you how you can actually hit some REST endpoints and be able to get that data back and represent that data inside your application, mixing game engine space and GIS location. So short answer, no, but there's some stuff that can be done even for unsupported data type currently.
I guess one thing I'd like to add there, just to keep in mind that one of the pivotal requirements, the value add with the Maps SDK is the ability to access ArcGIS data sets, just to reiterate that. Those data sets can be hosted through Enterprise, they can be hosted through ArcGIS Online, can be accessed through ArcGIS Platform. You can create packages with Pro or services, and those packages can be used locally by the Maps SDK with your application. The key is that some of those data sets are fairly complex. So like I mentioned in my previous slide, some of those data sets can be quite complex. So you're not going to be able to create a reader and a renderer for that very easily. And that's where we want to be able to do the heavy lifting for you. So when you're working with things like our I3S specification or PBF that's coming back from a vector tiled layer, there's some complication there, and that can be quite complex to be able to handle on your own. So we want to be able to do that heavy lifting for you to be able to access those ArcGIS data sets specifically. There's other formats, there's other data sets, for example, feature services, working with dynamic map services, where the RESTful API is available to you, and you can use different web request systems that are part of the game engine to make requests and actually process that information and utilize that raw data within the game engine yourself. So the bar is a little lower for those more the services that provide a more simpler structure or a simpler structure that you can utilize. Now that said, we're really focusing on ArcGIS, the system. We're not necessarily focusing on non-proprietary separate data sets that are outside the ArcGIS system. The benefit here with the Maps SDK is we want to be able to enable access to the ArcGIS system, which means services and packages that are created and proprietary to the ArcGIS system. Something to keep in mind.
Okay. Next question, any advice on minimum requirements for the machine to configure the 3D engine?
I think that's really depend on your final application, because the ArcGIS Maps SDK are really trying to get the performance, the best performance possible to be able to run on mobile devices, very low-end specification, to very high-level machine like the one we use for the UC plenary. And so I don't think there's really a specific type of minimum requirement for the machine you're going to use to render your application. It's really depend on the type of application you want to use. So I think that's more purely a game engine question, which is, you can go to the game engine Unity forum and Unreal forum or documentation and be able to find for the type of application, types of platform you want to run your application on, what type of hardware you should have. But there's no really a requirement that is added by the Maps SDKs. It's really purely, I think, a game engine question.
Okay, thanks, Adrian. Okay, I think this next one's probably for both of you guys. Is City Engine still a separate project? Is it not integrated with this work? I know City Engine was used in the plenary project that you worked on, Adrian. Maybe you have some comments about how it was integrated and so forth.
So City Engine is a separate product, and in terms of production of the data, you can kind of consider it as Pro, with obviously way more targeted scenario, but which means it's a content creator. And so from City Engine, you can create your city basically and be able to export that as a scene layer, and then you can consume it using the ArcGIS Maps SDK, host it in ArcGIS Enterprise or anywhere we want, and be able to consume it in the ArcGIS Maps SDKs. That's one way to go from City Engine to the game engines. The second way doesn't use the Maps SDK at all, and that's the capability of exporting data from City Engine using Datasmith of FBX and be able to import that inside game engines. Nothing to do with the ArcGIS Maps SDK, but that's also a process that works. And third, there's also the capability right now only available for Unreal, is to be able to run the City Engine SDK, so there is a power of generating an entire city with just a few city engine rules directly inside Unreal Engine. So don't need to import data, export data, and actually create that data directly inside. Why not just Unreal? So those are the different way you can interact between City Engine and Game Engine. And there's only one way where you actually use the ArcGIS Maps SDK is when you export it as a scene layer, either package or online service, and then you'll be able to consume it with the Maps SDK. But what's really important now is that with the geo placement framework for both Unity and Unreal, you are able to bring data from all those different sources and represent them directly in the world at the right coordinate. So yeah, I think that's going to be a huge benefit of using our new geoplacement framework.
Okay. Do the input layers need to be 3D layers, or will the game engine support overlay of 2D data layers as well? That's an interesting question.
This depends. Well, so we've got a number of different layer types. Some are optimized. Obviously, I3S is one specification that's optimized for use in 3D, but it's not required that you have really a Z component or a height component or elevation component with your data. Again, the key part there is being able to access and work with your data in a way that you can then display or demonstrate or visualize that within 3D. That might be information that you assign on the client. So if, let's say you're working with a feature service and that those features don't have Z values, but you'd like to have them, let's say, snap to a surface, you want to be able to assign elevation values or height values on the client. Today, what you need to do is, number one, we don't support feature services right out of the box, so you'd end up having to work with or create basically work with our web request system, a web request system within the game engine, make a REST request to the feature service, get back features, which is geometry and attributes, and then use the game engine's rendering capabilities to be able to draw those features actually within the scene. Now, at that point, you'd have the ability to assign values. You could lock it to a specific surface if you choose to. You could assign different height values. You have the ability to add or supplement information associated with those features. Now, of course, if the features themselves have, if the information, the GIS information has Z values, then we can respect those as well, and we intend to. So there's no requirement to use 3D enabled data. You can leverage or at least take advantage of data that does not have a sort of a 3D component to it, and choose as a game engine developer, again, this is a developer product, choose how you'd like to render that within a 3D context.
Thanks, Rex. Okay, we're down to the last few minutes, so this is probably the last question. Is the coordinate reference system always WGS84 Web Mercator?
So that's a new capability that Rex had in his slide that will be coming for our first production release. So right now, yes, it does need to be WGS84 and Web Mercator in both local and global. But we have the target of supporting WGS84, Web Mercator, and CGS 2000, I think it's called,
That's right.
for both global and local mode. And then also in local mode, be able to support all those projected special references. So that's what's coming in the first release. But for pre-release, yes, it's only WGS84 and Web Mercator. And before, because I think that was the last question, I just want to insist on the beta forum and the user forum here. Because when you answer a question there, it's not a separate team that answering the question, it's directly the dev team that is working on the ArcGIS Maps SDK, that is looking at those posts and answering all the questions that are in that forum. So make sure that you post, all the questions that we couldn't answer today, and also, any features that you would like to see. Because it's a direct connection. We are dev team, it's pretty rare. Usually you do have some moderation happening, but that's not the case here. It's really directly the dev team replying to those questions and those feature requests. So please make sure that you use those forums to be able to communicate and maybe get some tips and tricks from different users on how you can do different things. Because that will have a direct impact on our roadmap and which feature we will release later.
Okay, thanks, Adrian. Okay, with that, I'm going to go ahead and hand everyone over to Amy.
All right. Thank you, Stephen and Adrian and Rex. And thank you, everyone, for attending today's webinar. Get ready for the ArcGIS Maps SDK for game engines. If you have any questions about this webinar, as Adrian stressed, we encourage you to post them in the Esri community under user forums, as there may be others who share your same question, of course. Once you leave today's webinar, you will be receiving a survey on the presentation, and we would appreciate it if you would complete that and provide your feedback. We will be providing a recording of this presentation, which will be available within 7 to 10 business days on the GeoDev webinar landing page where you registered for the webinar. On behalf of Esri and our presenters, thank you for joining us today and have a great rest of your day.